Hi, this is Stacy Higginbotham with GigaOm. I'm here with Nick Feamster of Georgia Tech, and he's going to talk to us about a project that he's developed called Lithium. So Nick, thank you for doing this.
Thanks very much, Stacy.
Can you tell me a little bit about what Lithium is?
Yes, Lithium is what's called a software-defined network controller, and the goal of Lithium is to make network management easier for both network operators and the average consumer.
All right, so let's back that up for a second. A software-defined controller. What does that mean?
So the conventional network is often configured at a very low level with low-level network configuration commands. And software-defined networking is a trend that basically makes networks more easily configurable by software programs. That leaves open the question of how that program should be written and what that control should be. And Lithium is one way of basically making that control a lot easier for users and operators to actually configure.
So I, as a user, what would that mean for me? Am I configuring my home network?
Let's take an example, for example, your home network, where for example, you might have competing applications, or you might have things like usage caps. So for example, you might have multiple users in the home, one of which might be running a very bandwidth-intensive process like file sharing, and another might be involved in a more delay-sensitive process or interactive service like Skype or gaming. I mean, you might want to make sure that that bandwidth-intensive process doesn't interfere with the more interactive or real-time traffic. So this type of policy is very difficult for the average user to define. And moreover, these types of things may change depending on who the users are, what time of day it is, and so forth.
That's true. My daughter's gaming. I don't care when it comes to like my Hulu.
Exactly, and depending on who's home, what time of day it is, what day of the week it is, etc., you might actually want to define different kinds of policies. Another example might be when you have a guest come over, right? You might actually want to give them different kinds of access control and give them different levels of priority. And these types of things are very difficult for existing users of existing networks to configure. What Lithium is trying to do is actually make these types of policies easier. The high-level idea is what we call event-driven network control. The idea being that a lot of what you want the network to do is based on events. Like a certain thing happens, like it becomes a certain time of day, or a guest arrives. And all you want to do is basically tell the network what to do in the instance of a certain event. So Lithium is basically geared towards making it very easy for users to basically tell the network what to do when certain events happen.
So how would I interact with Lithium today versus what do you see it looking like in the future?
So there are basically two levels at which one can interact, two levels of abstraction. One is so I guess to understand the context a little bit, currently users and operators have to operate at very low levels of network configuration, sort of very vendor-specific level. What we're doing with Lithium is developing a language that allows people to very easily express or concisely express what the network should do under certain conditions. The interesting thing about the way that we've developed that language, though, is it basically makes it very easy to develop clean user interfaces on top of that. So we've also developed a graphical user interface called UCAP that allows users to configure things like usage caps through a very easy web user interface.
So is Lithium right now like a C++ kind of language? Is it Python? Is it something like, what level of language are we talking about?
Currently it's C++,
okay.
And we are working on extending it to higher level languages.
Okay, and this GUI that you mentioned, what was it called again?
The current GUI that does usage cap management is called UCAP.
UCAP. Is there a way I could download this, and where would I run it as a consumer?
Basically, what we're doing right now to allow consumers to use it is, we're releasing it on a fairly limited basis. So if you want to run this yourself, you should contact us, and we will basically ship you a router that's running our specific, our firmware. If you're comfortable with installing the firmware yourself, you're welcome to do that. But what we would do basically is ship you a router that's basically an open flow router for the home. And then you can configure that through the web interface that we provide. So we'll basically just point you at a URL, and you've got basically cloud-based management of your home router.
That's awesome. Is anyone doing that commercially yet?
There are a few commercial providers who are doing similar things. So for example, Cisco recently announced something called Cloud Connect, which allows similar kind of cloud-based management of home networks. So basically, what we've got is a sort of open open flow-based equivalent of that type of framework. What we hope to do as well is explore, because it's open, what we're hoping to do is explore the different types of things users want to do in their home networks to make it more easily extensible.
And let's go real fast to the kind of operator side, because another promise of something like this is if you can help users and at your own network use bandwidth more efficiently or optimize it a little bit better, what does that mean for how operators' networks can run and kind of, yeah.
So I'll give you like a specific example that I think is coming to the forefront. So as users increasingly are using bandwidth-intensive applications like over-the-top video, the access link is becoming increasingly constrained. So obviously the first thing operators are trying to do is install usage caps. Right? So one thing, of course, is we can help users manage those caps through a Lithium-based controller. But I think as we progress, we're going to actually see much more sophisticated types of ways of managing this limited resource. So for example, as opposed to just capping, an operator could do a whole bunch of different things. So for example, only cap certain types of applications, or only cap during certain times of day, or perhaps rate limit or adjust pricing based on what historical usage patterns have been. Now you can imagine these things might actually make life easier for the operator, but it becomes a management nightmare for the home user. Right? How do they figure out how much Netflix traffic they've used for the month, or how do they figure out whether or not a particular application is going to be rate limited, or how do they automatically schedule their network traffic so that the backup traffic, the backup process doesn't interfere with something else that they're doing, in light of what the ISP has configured in terms of performance. So what we ultimately envision things like Lithium and UCAP being extended to do is help the user manage their own home network traffic in light of what these more sophisticated ISPs policies might be. And if the user could do that, right, then it might not be beyond the scope of what of the ISP's policies to enable more efficient and sort of more sophisticated types of policies. One of the reasons that I think caps are being used is that it's a very easy thing for a user to understand, and it's a very easy thing for an ISP to implement. Right? But as we move more, as we see the software-defined networking trend evolve, I think what we're going to be able to see is that it's going to be more, it'll be easier to manage network complexity, right? Both for the operators and for the users. So what we're going to see, I think, is that both ISPs should be happier because they'll be able to implement more sophisticated, more efficient network policies, and users should be happier as well because they're going to have a much easier time managing their home networks through much more intuitive interfaces.
All right. Well, thank you so much, Nick.
Thanks a lot, Stacy.